Here's a template class. This is a very naive accumulator. It keeps a running total. It's not necessarily a paradigm of exactly how to write accumulators that keep running totals. There are things that will do this for you in the standard library, but I wanted to choose a class that you could easily see how it worked. This is in a header file, and there is no accum.cpp. That's pretty normal that everything is in the header file so that it can easily be brought in by the compiler everywhere that it's used. As with the functions, you notice we start template class T. And then we are defining a class, and this is the end of it as usual. And inside we use T for the type placeholder, just as in the function. So accum here, if you're making an accum of ints, it'll have an integer total. If you're making an accum of floats, it'll have a float total. It has a constructor that takes a starting value. It's probably going to be 0, but we're going to have a constructor that lets you pass in what your starting value will be. And all it will do is, using C++ initialization syntax, initialize total to that starting value. Then we have an operator plus equals. It returns a type and takes a type reference. I'll explain the const later in the material on pointers. We'll get into const. For now, when you take certain things by reference, you have to say const, otherwise you can't pass in a literal like 3, which is a constant. Treat that as a little bit of a magic word for now. We'll come back to it. Operator plus equals. This is just ordinary common or garden operator overloading. When you add t onto the total, we should increment total. So total is equal to total plus t. And we'll return that value. That may be of some value if people are chaining them or using them to pass down to other functions and that kind of thing. And then I have a member function called getTotal that provides access to the total. And it is returning type t again. So if total's an int, this returns an int. If total's a float, this returns a float, and so on. And I have some code here that uses it. Now when you instantiate a template class, you do explicitly specify the type. So here I'm saying I have an accum of int, and I've happened to give it a name integers, but you could of course call it hello or Tuesday or whatever works for you. And I'm passing in a starting value, which makes sense that we start at 0. And then I just use plus equal a couple times and add more integers onto my accumulator. And then I ask for the total and print that out. Do the same thing with strings. I call it strings, and this time I initialize it to quote quote rather than 0. That obviously makes more sense for strings. And I'm going to put in hello and world. And the rest of the code in this main is commented out. So let's just run this and show what you get. So when we put 3 and then 7 into the accumulation of integers, we ended up with 10. And we put hello and space world into the accumulation of strings, we ended up with hello world. So this works as advertised. That's nice. It's good, simple, easy to use. And apart from the angle bracket syntax when you declared them, after that it's just perfectly ordinary class, and you just use these intuitive operators and member functions. Now what do I have commented out down here? I have attempt to break the rules. I've mentioned a couple times that templates give you type safety. Integers is an accumulation of integers, and its plus equals operator takes an integer reference. When I try to use a string, you can see I'm going to get red wigglies. It says no operator plus equal matches these operands. And similarly, strings is an accumulation of strings, and when I try to add in an integer, it says no operator plus equals matches these operands. I will build it to show you the compiler errors that you get in the output window. There's a lot more of them, and they can be a little more intimidating. They do contain the same fundamental complaint that you saw in the tip. No operator found, which takes a right-hand operator of type const char at 8, and then showing you that this is int accum of t's operator plus equal. And just that, seeing t here and here, is your biggest clue that if it's an accumulation of integers, you should add integers into it. And if it's accumulation of strings, you should add strings into it. This kind of type safety is a feature. This is what we want our templates to do for us, to let us write the code once and use it with a variety of types without forgetting what the types are, keeping all their true nature as an integer or a string or a person or a bank account and getting the compiler, our friend, the compiler, to tell us when we mess up. So these lines don't compile because our accumulator is type safe, and that's what we want.